We are exploring the AI rainforest, a space where we discuss a variety of intersecting topics like large language models, use cases, AI agents in Web3, reputation, and the innovative businesses and people at the forefront of this burgeoning space. Each episode features an expert in their field who shares their thoughts and opinions with us. Welcome, everyone. We are hiking through the AI rainforest today with Piet Martens, a gentleman with over 20 years of experience in data mining, machine learning, and artificial intelligence. He has published over 300 papers on a variety of topics and has been cited more than 5,000 times in other papers. More recently, he has turned some of his attention from outer space to finance and AI and was a co-author on the paper for zScore. Piet, welcome to the show. How are you today?
I'm great, thank you.
That's great. Thank you so much for spending some time with us today out of your busy schedule. Really appreciate it. And yeah, let's see where the conversation goes.
Right.
So let's get back to your roots a little bit. From what I read, in university, you studied astronomy, and afterwards you went straight into space research at the
Right.
Netherlands Institute for Space Research for your postdoctoral work. What first sparked your interest in space science and solar physics?
Well, I'm old. So I was a teenager in the 60s, and I was totally fascinated by the race to the moon. And I still remember the speech by John F. Kennedy in Houston is, "We are going to the moon. We are going to the moon, not because it's easy, but because it's hard." And I said,
Mm,
yes, I do. uh, So how do I get there? Well, I start studying astronomy in Utrecht, which had a space research lab connected to its astronomy education. And when I got there, they told me, "Don't choose this. Take an easier study because there are no jobs in this field." I said, "Okay,
mm,
I'll figure that out after I get my degree." So I did it anyway, and I actually did a thesis in theoretical astrophysics. So a lot of physics in it and a lot of math. I got that cum laude and then stayed a little bit on in the laboratory for space research there, which had good connections with several labs in the United States. And through those connections, I got my second postdoc at NASA, got at Space Flight Center in Maryland. Um,
nice.
no, that's where I met my wife. And so I stayed in the United States for most of the time. Went back to Europe for a bit, but uh,
So what were
so
what were those first few years at NASA like? Like what kinds of things were you spending your research time on and focusing on?
well, I was basically following up on my thesis research, writing a review paper, going further in the study of solar flares and filament eruptions, and which flares are a danger for astronauts. So already that interested me. There was a practical thing we could help with. And It was only for 3 years, the postdoc position there. So quite early, I had to start looking for something else. Uh,
Okay. But I mean
I thought,
that's still a pretty active area of research, right? Where from what I've seen in the not too distant past, we're still learning a lot about solar flares, about how dangerous they are, coronal
right.
mass ejections, protecting our electrical grids from solar flares and that sort of thing.
Right.
Did any of your early was you mentioned protecting astronauts? Was your early research focus exclusively on astronauts, or did any of it apply to
No,
stuff
no,
back
I
here on
was
Earth?
trying to do the theory behind it. What causes a solar flare?
Okay.
Can you predict when it erupts? That sort of stuff. I wasn't thinking about the radiation for astronauts yet. That wasn't an issue at that time because nobody was going back to the moon or to Mars at that point.
Right, right. Okay, well, you have had a remarkable academic journey. You know, you said you had to find something new after NASA. From what I saw, you you did that pretty, maybe not easily, but you did do that. You've had a
But
number of different positions at different universities, at other institutions, and as I mentioned earlier, produced over 300 papers with co-authors and such. Can you walk us through a little bit through your research there, how it, and into forecasting space weather and
right.
solar energetic particle events and things like that?
Well, what I really like doing is old-fashioned physics, astrophysics, with a pencil and a piece of paper where you write down equations and try to solve them and use them to predict things. This is sort of thing that Einstein did. I'm no Einstein, but that's it's the physics of the early 20th century. And I learned while I was there, this is not the way it's going anymore. I mean, it's great. I've done a whole bunch of papers where I did analytical solutions, pen and paper stuff, but that's not where the future is. The future is in large scale computer simulations, which people started doing in the 80s as computers got rapidly much better,
Right.
where you can just predict and simulate things that you can't do on a piece of paper. And then the next thing that came was machine learning, computer science. They call it now artificial intelligence, data mining and machine learning at the point. I thought, oh, that's a really interesting thing. So much later, with a colleague at Montana State University, we started working together. He's a computer scientist. I'm a solar physicist. So we could apply machine learning in solar physics and for predicting solar flares and for hazards to astronauts and so on. That came much later. And what you typically need to do such a thing right is a domain expert, somebody who understands the field that you're trying to make predictions in, and a computer science expert who understands data mining, machine learning. And so that's how we set that up. We set up a data mining lab, which is more than 20 years old now, and it's still working.
That's great. So, like, uh, what kind of results ended up coming from the data mining lab through that collaboration with the computer science
Okay,
expert?
yeah, there's tons of papers, but I think one of our main results is a curated database of all solar flares since the Solar Dynamics Observatory that was launched in 2011. And when you get data from space, there's always a lot of errors in there. And some of the parts of the data are actually annotated by human beings, and humans always make errors. and and if you have bad data, you make bad predictions. That's kind of obvious, right? So
Right.
we had to curate that humongous data set, which we did with a whole bunch of students, and then make it machine learning ready. It was something relatively new still at the time. And then we published it and made it open to the public, and we use it to predict solar flares. And we get quite a bit of improvement over previous results doing that. So that's hard work basically, and it's a group work. One person can't do it,
Yeah.
and from there on, we try to improve the machine learning methods to get solutions for actually real practical problems for astronauts. And only last year, I published with a graduate student from India who did most of the work. We made a very good prediction method through machine learning for solar energetic particles. And solar energetic particles are mostly protons. They travel with almost the speed of light, one third of the speed of light, so very high energies.
Yeah.
And when they hit astronauts, they can disrupt their DNA and cause cancer that way, or they can kill them outright. And they also have quite a bit of influence on hardware. They can mess up computers, disturb high voltages, and so on. So you want to be able to predict those things and then take protective measures.
Right.
Uh, and we came up with a method to have really high confidence predictions, but it's only 1 hour ahead of the actual event. So say, for example, if the US Air Force is planning missions, they want to know whether their communications will be disrupted by a solar flare. So they need predictions 2, 3 days ahead. It's not for that. It's for astronauts in orbit or actually away from Earth, on their way to the moon, for example. But an hour turns out to be good because that gives them enough time to get inside the spacecraft if this, for example, in the moon, and the spacecraft gives them a protection of a factor 10 compared to being out there, and that's enough to be safe. Uh, they get some radiation, but not at a level that it's gonna definitely not gonna kill them, and it's gonna make it tolerable. Like you get radiation when you go to the dentist, X-rays, and those levels are tolerable. Otherwise, they wouldn't do it, of course. But you still get those lead things over your chest, as I'm sure you know, to
Yeah.
protect you from excess X-rays. So I'm very happy with that, and now we're trying to do actionable things with that. We look at a potential trip to the moon, say 5 years ago, for we have the data of the solar energetic particle events and see, okay, how much radiation would an astronaut have gotten on that trip if we
Okay.
use our predictive method, and how much would it be without having a prediction? So they would be exposed more. So that's what we're working on now, and so that's a very practical application of the work we're doing. And actually, I like that when it has a very practical application. I think that's why I went into solar physics, because solar is practical for us. It has to do with climate change, although the sun is not the reason for climate change, but you want to know how the sun develops. It has to do with safety for astronauts when they go outside of Earth orbit. It has to do with protecting our electrical grid, for example, as you mentioned. A really big storm can mess up the electrical grid, and it has. In 1987, for example, it did, and New York City went dark. Um, so these are the practical uses of the work we do.
So, like you have lived through and been using a lot of this technology as it's being developed
Right.
up until this point now in 2025, where obviously computer this thing in my hand has more power than all of NASA had
It,
in the 60s
going
in
to,
in mission control.
yeah, do you remember the movie Hidden Figures, where they actually
Yes.
had yeah, three black women who did all the
Yeah,
calculations?
those are the
Black.
computers. Yeah, they were the computers.
Yes.
Um, well, not just the three of them, but yeah, like literally a room full of female mathematicians who
Right.
are literally doing the math and computing variety of scenarios and things like that. So to make sure, yeah, the rocket actually gets off the ground, actually, goes around the moon, etc. So I like what is that experience now compared to even in the 90s? We don't have to go back to the 60s or 70s, obviously, because it's the computers were incredibly primitive, or at least much slower than what's capable now. The programming languages are a lot more expressive now.
Yeah.
um like what's that experience like now compared to, let's say, 20 or 30 years ago?
Oh, well, everything is totally different. And now I can do most of my calculations on my laptop now. I don't have to go to NASA supercomputers, or just let it work overnight and you get similar good enough results.
No more
um,
timeshare required.
right. Yes. And you have to apply for time on the supercomputer. People do that. People who run very complex simulations. I don't do that. That's just not my thing. But there's still a need for it. But most of the work I do, I can just do on a laptop now, which is totally incredible. And that was incredible in the early 90s already. That you used the mainframe in wherever you were working at the time. Um,
Yeah.
and then, and as far as machine learning, that has really exploded. There's so many different methods and very subtle tweaks you can give to your program to get better results and so on. And that was pretty much non-existent 30 years ago. I
Yeah.
mean, some big ideas have been developed, that's true, but not worked
Right.
out.
I had to give one of my stepdaughters a bit of a history lesson yesterday, because she asked if we had, when I graduated high school, if oh, what did she call it? Senior assassin, I think it's called. And the whole point is that on Snapchat or something similar, everybody gets to see everybody's location, and you have certain rules, and you're supposed to assassinate, quote unquote, somebody with a squirt gun, a water gun. Um, within a certain within certain parameters, like you can't go to their job and like
Right.
go into a Walmart or whatever and shoot them with a squirt gun. That's embarrassing. They're at work, leave them alone. Some free for all time on the weekends and stuff like that. And she's like, did you guys do that? And I said, Most of my friends
Like
didn't do
cowboys and Indians.
phone. Like I was I had a job, from like 16 onwards. So in grade 12, I had my own cell phone that I was paying for myself.
Wow.
And I was lucky I could T9 text on it, let alone, get internet or location data or whatever. And she was like, "What? You didn't have that?" No, I didn't have that. And that's, a little over 20 years ago. Never mind 30, 40 years ago. Like, no, there was no, senior assassin game. We could have organized it, but we would have had to put everybody's name in a hat and
Right.
pull it up the old style way. And yeah, you still set your rules, but like you're going to the mall and hoping for the best, or you're going to the store and hoping you run into your friends, or a bowling alley or something, or the arcade. You're not looking at your phone and being like, oh, Bob is at his grandparents' house or something. Like no, that literally was not possible at the time.
Yeah.
GPS was still new, or at least publicly available GPS through your TomTom or your Garmin device or stuff like that. That had only been around for a few years.
Yeah.
So anyway, yeah, it's definitely, I'm 41. Things have changed
Yeah.
dramatically in my lifetime, and even more so
In my
in
lifetime.
yours. Going back to your work, like I said, you've published hundreds of papers. It's been cited a lot. So, I would argue you're pretty well regarded in your space, or at least highly cited, which I know is
Right.
a good thing. We talked about, well, you just mentioned this database of curated, machine learning ready solar flares, which is actually being used now to help predict and notify
Yeah.
astronauts and people like that something's coming. You should end your spacewalk, get inside. Are there any other projects or bits of research that have had real world impact?
Well, I've been working on understanding solar filaments, which are dark filamentary structures on the sun. At some point, they erupt. Not all of them, but most of them erupt, and then they drive the really bad interplanetary space weather effects. So they
Mm,
drive coronal mass ejections. They drive the acceleration of solar energetic particles. So they're kind of at the base of what of all the negative effects you can have from space weather. So, and you see them before they erupt. They can be present for weeks. So I've been studying that with my students for years, really. I published my first paper on that in 1989, I believe, and which is still cited. I'm very excited about that.
that's a good sign.
And so yeah, we're trying to understand the physics and trying to predict when they erupt. Now that's a real tough one, and I don't think we've cracked that nut yet. Uh, but we can just keep on trying, keep on working on
Yeah.
it.
I was you kind of cut off the potential question there, but I was going to ask about how much progress you feel like you've made towards that. Like, do you have do you feel like you've got the beginnings of a model to even somewhat accurately predict them, like
Oh yeah,
50% of the time, 60% of the time?
yes. And in particular, the people who do really complex numerical simulations on big computers, they're getting close. They're closing in into being able to model each individual event and then say when it's going to erupt. On the other hand, I've done really basic, sort of old-fashioned analysis work with a student of mine, Aparna, and we just looked, some filaments, some eruptions have a big influence on the Earth's magnetosphere, cause polar aurora, etc., and they can disrupt electricity grids, and others don't do a thing. And it depends on the orientation of the magnetic field in the erupting thing. So what we set out is, okay, we'll look at the orientation of the magnetic field on the surface of the sun of that filament and see if that corresponds with the orientation when the eruption finally hits the Earth. And it turned out to be a very good correlation between the two. And nobody ever had looked at it, even thought about it. So now we can, almost 80% of the cases, we can know beforehand, oh, this one is going to be dangerous, that one, don't worry about it. That's a step forward, definitely. We're
Yeah.
actually running numerical simulations now to see if we can reproduce that result.
Okay, that's good to hear. I just realized I didn't ask about any of the source of this data. Like, obviously, Hubble's been out there for a long time and had
Yeah,
specific purposes. The James Webb
right.
telescope is out there
They
right now, which
at the sun, any of those. Neither Hubble, neither James Webb. They look away from the Earth in the other direction,
right,
away from the sun in the other direction. Sunlight is a real hassle for them. We have a whole bunch of specific missions that are geared towards the sun, and we have chains of ground-based observatories that look for example, that can observe H alpha light that makes it through the atmosphere. So there's a whole chain of observatories around the world, so you can look at the sun 24/7 with them working together, um, because of the day-night cycle, obviously.
yeah,
And then there's a whole bunch of missions that look at the sun in X-rays and extreme ultraviolet rays, etc. That's the radiation that doesn't make it through the atmosphere, so you have to go in space to look. So I've worked with data from all these spacecraft over the years, and they're now easily available. One of the things we started 25 years ago is create the virtual solar observatory, which is nothing more than an app, really. We designed it on purpose that way, but it knows where all the data are. So if I ask the virtual solar observatory, give me the data for the flare of the 14th of July 2007, if there was one. It was a Bastille flare. I forget the Bastille Day flare. I forget the exact year. Then that can tell you, okay, there's data there, there's data there, there's data everywhere. Those type of data, you can download it. Just push the button. So we thought that was in 2000 that we came up with that idea. That was pretty novel at the time. Now everybody has it, of course, but
right.
still is very useful, and we keep on maintaining and expanding it.
How does that compare to so that's, yeah, the virtual solar observatory. You do have that on the website, on your website, and I did remember reading about that yesterday. How does that compare to the innovative imaging hub? What's the difference?
Oh, that's really a really talented colleague of mine, Stuart Jeffries, set up that. And what we want to do is look at imaging not just from solar physics, but also from astrophysics. And what's more important, from our medical colleagues in another department, but at the same university, they look at X-rays of people, and they look at imaging of the brain, and they look at, well, I can't give you all the details, but because I'm not an expert on it, but uh, and it turns out there's a lot of overlap in the techniques we use to make those images better and analyze them and extract data from them, and then study them with machine learning. So we had every other week meetings together. Somebody gives a presentation, and we see what we can do together. That's the imaging hub. So I'm there as the expert of solar physics.
Okay. Well, more recently, you've taken a bit of a turn towards finance.
Yeah,
That's definitely not inside your normal wheelhouse.
right.
What's leading you in that direction to start looking at finance or AI in finance and that sort of thing?
My daughter. My
The
daughter.
one we both know.
Yes, yeah. She she lives in Holland now with a partner, and my two grandchildren, so I visit often. And she works on blockchain programming, and she's been extremely successful in it. She's got a regular job, and then she gets contracts from all over the world to do a blockchain program. And she tells me, well, Dad, I'm working with this company, and they really need an expert on AI, machine learning, to help them with their project of getting a financial score, financial reputation for blockchain transactions rather than real finance in the traditional way, where everybody has a credit score, but we don't have credit scores in blockchain.
Right.
Uh, so I said, all right, I'll look into it. That sounds interesting. So with that paper that you mentioned, I just helped with the AI part. But it's fun because I like learning new things, and I learned a lot from while reading the liter or reading up in the literature. So I knew at least when they were using terms that I understand what they're talking about, which is not simple in cyber finance because they have all these acronyms and terms that you just got to learn if you want to be part of the discussion.
Yeah.
So I did that, and I thought it was very interesting.
That's good. Yeah. I did myself a couple of edits on the first few drafts just for grammar,
Right.
consistency, that sort of thing. Not because I'm an AI expert, more because I'm a native English speaker. That's was
Right.
the big reason why.
One of the few, probably.
But even from that perspective, yeah, like I do have a background in finance, um, and working for a prior organization who wanted to build an alternative credit score.
Right.
And I didn't find it that interesting for me as a Canadian because we have a fairly robust credit scoring system here, same in the United States. It's not perfect, but
No.
it's much better than it is elsewhere, and it's actually less biased here than it is elsewhere too.
Oh, I had no,
Toward
no, I had no idea it was so much different outside North America.
Yeah, and like some big differences, at least that were true, let's say 7 years ago when I got started there, was in Portugal and Brazil, you don't get good history reported to the same organizations often,
Uh,
only negative. So you
right.
have no credit score in or no credit report until you take out a loan and miss a payment, for
Right.
example. Which obviously, I mean, yeah, that's important data. You missed a payment, but what about the last 30 on time payments in full I made? Which do get
Right.
reported here, but not over there. In the UK, being a registered voter with an accurate address boosts your score. That's not the case here.
What?
These are really weird idiosyncrasy. I remember there being one about France, but I don't remember what the idiosyncrasy is. So anyway, I got started with a prior organization who wanted to build a decentralized identity and alternative credit scoring platform. I thought that was incredible, not for me, for my family back in Portugal, and for others. And
Right.
so I got heavily involved for years there. And so when I got an opportunity to work with Ashutosh and eventually Devin, who I helped interview, and all that, I thought, yes, somebody's taking another crack at it.
Right.
It feels better this time. It feels more well thought out. We have a lot of history now on chain to actually review, and help come up with that score, and a bunch of other stuff we can bring in now much easier than we could in 2018, and tie it back to your wallet and tie multiple wallets together and
Right.
your real world credit score. And examples cited are like your Uber driver rating or your Uber passenger rating and all sorts of other things,
Right.
more as a general reputation score, as and in addition to obviously your on-chain financials. Yeah, so I was asked to review the first few drafts for grammar, language, consistency, etc. And even through that, I'm like, yes, this is a much better attempt than we
Right. Right.
had, or and more comprehensive, more well thought out. Thanks in part to more data and more ways to connect that data together on and off chain. And so from that perspective, it's a really exciting time. So you said you were brought in to kind of focus on the AI side of things. Was it similar in the sense that I'm going to
Yeah.
assume somebody who's read this is at least somewhat familiar with the terms, but if not, you can go read the paper on
Right.
Archive. This idea of finding certain kinds of clusters,
Right.
grouping them together, that sort of thing. Is that similar to what you're doing
Yes.
before?
Those are techniques you use depending on the kind of data you have. The interesting thing of this paper was there was no real end product to compare with. So when you predict solar flares, you look at data. Sometimes a flare happens, sometimes it doesn't happen, and you want to predict that. That's a binary choice, right? Here we did. There were no credit scores in cyber finance. So what are you going to compare with? What's your goal to achieve? And clustering is exactly the right method to it. That wasn't my idea. That was I don't know who came up with it, but it was a good idea. Uh, uh, that's just you look at the data without any prejudice, and you just see how they organize themselves. And
Right.
that's what
Yeah.
should be done.
Yeah.
Um,
Well, I think there was some unfortunate numbers wise, but fortuitous timing wise incidents that have happened throughout the first quarter of 2025, where we were actually able to compare the data and the end
yeah,
results, the scores themselves on the same platforms, right? So Aave, for example,
right.
Ashutosh, one of the co-founders of Zero, actually put out some posts on X showing that in a kind of a black swan bad market day 6 weeks ago,
Yeah.
any of the wallets with a score over 500 were not liquidated that day. Those were
Yeah, that's what
good.
exactly what I was going to say. This is what you should do, and yeah, and they have.
Yeah, and so yeah, so basically these opportunities have been presenting themselves,
Right,
giving the team an opportunity to actually check the data, make an adjustment if
right,
needed. But so far, so good from what I've heard, and therefore a Z score of like 400 plus, 500 plus, so far is a great indicator of whether or not you are a responsible decentralized finance user.
right. Yeah,
So yeah, it's working out so far.
good. So yeah, I've actually worked on a very similar problem with a student of mine. It's just published like a year ago or so, where we used historical data to make predictions, and in Zero Finance could do that too. Say you put the clock at January 1st, 2020, and you use data from before that time to train your algorithm to get credit scores in this case. And then you see how well it works out for the time after that. So you don't have to wait for new data like you had in 2025. It's great, but you can also use all data that way, just
Right.
simulate real time, what we call simulated real time prediction making.
Yeah, and basically look at, I guess, other, big down
Event.
days in
Yeah,
markets, the price of Bitcoin crashes, price of Ether crashes, et
right,
cetera, and see how those same wallets do, or whether they were liquidated or not.
right. Yeah, exactly.
Yeah, good stuff. Okay, so yeah, I guess you came into that, I guess, kind of fresh, but as an individual at your age, you have and living in multiple different countries, you have experience with credit markets in general. Um, do you have any opinions about traditional credit scoring models? What zScore is trying to show and improve on. Like does zScore propose something better in your opinion?
No, I had some thoughts about improvements, but we still haven't worked out my contract. But I'm sure that will work out in some way in the future. I'm not really worried about it. So, in the end, the Z score was just given manually. I mean, you have the different subgroups that you found with a neural network, but then there was just a score attached to that, which was just waving your finger, waving your hand, right? And there are actually mathematical models to improve that. So you come out up with some equation that gives you that Z score, which has parameters in it, and then you find the best parameters to give you the best end results.
Okay,
So
fair enough.
that's not a complete change. It's just a gradual improvement of the system. But it does make it more credible, I think, for outsiders, because if they really read the paper in detail, they'll figure out how these guys just use the wet finger to give credit scores to these seven groups we have. Uh,
Yeah,
anyway,
and I guess from my perspective, I mean, you need to start somewhere, obviously,
no,
and I
no,
think
it's a really good idea. No, I'm not
yeah,
criticizing. Just
no,
saying
no,
that.
and I'm saying we have to start somewhere. So yeah, maybe it's a little
Yeah,
like you get 50,
if it
50 or
works, it works, right?
sorry, say that again.
if it works, it works. So
Yeah, but
that,
I mean, I
that's
know that there's a big effort now to add more data to the data set, other lending protocols, trading protocols, um, looking at loyalty for in decentralized
right.
autonomous organizations to see if those have any strong signals, correlative signals, that sort of thing. And so, version 2, version 3 of zScore, I'm sure is going to be coming. I'm sure V2 will happen at least this year, maybe even V3, who knows? And yeah, and hopefully smart individuals like yourself will continue to lend their time and their expertise and continue to improve it and improve this entire area and all of what's possible in data mining, machine learning, AI going forward.
Yeah. So my plan is, since I'm about to retire and I actually want to leave the United States, just like the rest of my family, I'll come to Canada. But Canada has cold weather. uh,
Uh,
but I was
not,
thinking,
it's not better weather than where you are now, I don't think, but that depends on what kind of weather you want.
yeah, well, I want dry, sunny, not too hot, pleasant. So I was thinking somewhere south of Spain or Italy to retire. And when I'm not working anymore, I know that I need to do something. I need to keep my brain busy. So I figured out I can do this kind of stuff. I have a lot of experience with AI, and I can help my daughter, and I can help whatever company wants my services, and just work part time on that with contracts and just give them what they need. And if it works out, that'd be a great thing to do. And as I said, I'm very curious by nature, so I really enjoyed reading up on how uh, uh, blockchain finance works. It's really a fascinating concept, and I really hadn't given it much thought until a year ago. But
Good stuff. Well, I know the teams really enjoyed the AI teams really enjoyed your feedback and your expertise on zScore, and hopefully we can continue that relationship and continue to improve zScore, and you'll see where else you can apply your
yeah,
expertise.
right, right. We'll see how that goes.
Okay. Well, I was going to ask you about what's next, so you already answered that, so that's terrific.
Sort of had
I'll
that fantasy of me sitting on the town square overlooking the Mediterranean, drinking my cappuccino and working on my laptop and whatever needs to be done. And
That
that,
sounds like a great way to spend your time, period.
right.
Good stuff. Do you have can you share some parting thoughts on where maybe your research is headed, or just the kind of the power that AI the power of AI could be applied to other things it could be applied to, either in your previous or your main field of
Yeah.
astrophysics, physics, or in finance?
Well, one thing I found out is ChatGPT and the others as well are really helpful with programming, because you
Mhm.
can just ask for a program that suits your needs and it'll find it, because it's really not a Google with a voice basically, but it's, uh, and so that makes programming a lot easier and a lot quicker. I think that's a great progress that we'll have. What I for the rest, I think AI is really hyped a lot, especially here in the United States. It's not as impressive as it's supposed to be, and they just want to sell their products. I get the impression. Uh, I've used ChatGPT to write a letter of recommendation for one of my students. So I had a draft, and I said, "Okay, improve it." And the outcome was just terrible. Really beautiful sentences, but all the things that were specifically good that I wanted to convey about my student that he was really good at, they left that out. It was just a generic letter of recommendation, and I was really disappointed. So I'll still write my own letters of recommendation. Um, and the other, what I really found interesting, that this Chinese company, I forget its name, came up with a version of AI that uses far less power and far less chips, and it works
Deep sea.
pretty much just as well, from as far as I can tell.
Yeah, I
So
don't
yeah,
remember the name, but the model's called DeepSeek.
oh, that's it. Yeah, right. So that's interesting. I don't think I'm going to be able to make contributions in that field, but it's definitely worthwhile keeping an eye on it and trying to learn what's real here and what's not real.
Stuff. All right. Pete, thank you so much for your time today. We really appreciate it. And I hope you will all join us next time as we continue to hike through the AI
All right.
rainforest.
Thank you so much. It's been a pleasure.